Okay, let's go over this chapter 3 practice exam. See how long it takes to go over all this, but I promise you, if you can do this practice, you should feel very confident on the actual test. Okay, so this first section, you can check on a calculator. I'm going to do this without a calculator, but I would definitely make sure I take the time to check on a calculator. I don't want you to get one of these wrong. So this first one is a subtraction problem. The first part I don't change, but since we're subtracting this entire quantity, it's going to become a plus 6 plus 7i. And what I need to make sure is keep it in what's known as standard form. So the real part goes first. We're going to have a 5 because negative 1 plus 6 is a 5. And then my i's become a 3i, a positive 3i. And we're finished. And I promise you, you check it, type it in your calculator, it is correct. For this second one, it is where we have to use the distributive property twice, so which is really FOIL. So I'm going to take 6 times 5, I'm going to get 30, and then 6 times negative 8i is a negative 48i. Inside, I'm going to get a negative 35i. And finally, this is going to become a plus, and 7 times 8 is a 56 I squared. And you have to remember, if you type this in the calculator, you don't have to worry about this. But if you're going to do this by hand, then you have to realize this really means 56 times negative 1, which is really a negative 56. So when I combine my numbers, a 30 and a negative 56 together is negative 26. And then we're going to have this. When you add your i's together, they're both negative. It's going to come out to negative 83i. Okay. Again, it's really easy to just type it in the calculator. So for this third one, I'm actually going to just remind you of how to type it in. So if you're, let's zoom out on this so you can see the actual entire calculator like that. I have a 5 minus 3-second period is where you get your I, close the parentheses and square it. And you can trust the calculator. It's going to be a 16 minus 30i. Okay. Now I'll show where that comes from. If you take, let's zoom back in on this. When you square something, it's itself times itself. So I'll justify where this answer came from on our calculator. 5 times 5 is 25. My outers and inners are each going to be negative 15i. So I have 2 of those, and that's where the negative 30i comes from. But then I'm going to have negative 3 times negative 3, which is a positive 9. I times I is I squared. This really means negative 9. A 25 and a negative 9. When you add them together, that's where the 16 comes from. Okay. So this last one, again, you can just simply type in the calculator exactly how you see it on paper. If you're not going to use a calculator, you're going to have negative 6i squared. I times I is I squared. I'm going to distribute the 8. So 32 minus 48i. This really means a plus 6 because negative 6i squared is negative 6 times negative 1, which is a positive 6. 6 plus 32 is 38. And we have the minus 48i. Okay. All these are in standard form. Again, that should be easy points. Okay. Don't get that wrong on your test. Now, this was on your quiz. I warned you about this. You practice this on big ideas. This looks goofy. If you're not looking at this, it looks difficult, but we need both sides. So basically, I have 15 minus 4i, and it has to equal 15 minus 4i. Okay, for that to happen, this and this, I set equal to each other. I set the real part. I know this has to be a 15. What negative 3 times what is a 15? Well, if I divide by negative 3, I'm going to see that x has to be negative 5. Obviously, if you take negative 3 times negative 5, it's 15. We have a 15 on each side. So x is super easy to solve for. The y is just as easy. Yes, we're going to divide, but we can use a calculator to divide by 2/9. So set this part equal to each other. Okay, they both need to be at minus 4i. So minus 4i equals 2/9 yi. The i's just cancel each other out. I have i's, so I'm not even going to worry about the i's. And then to solve for y, I divide by 2/9. Okay, now if you're going to use a calculator, make sure you put it in parentheses. Okay, so I have negative 4 divided by parentheses 2 divided by 9. Okay, that's how the calculator reads 2/9. It tells me, hey, this has to be a negative 18. And it's correct. It's the only 2/9 times negative 18. You calculate that, you'll get negative 4i on each side. Okay, super easy. Here's an application problem of a square root problem. Okay, this is a simple formula that we should easily be able to solve for t. So in this case, t is time in seconds, and d is, and be careful of this, so you have to make sure you read this carefully. Your d is the length of the pendulum in inches. So if I tell you that d is 74 feet, you need to multiply by 12. Okay, 74 feet is really, and I'll show this on a calculator, we should know 12 inches in a foot. So 74 feet times 12, 888 inches. That's what my D is, okay? So in this formula, I'm going to replace the D with 800. That's a huge pendulum. And then I'm going to solve, and this is nothing more than a square root problem. Okay, so in 2 steps, we'll have our answer. I'm going to divide by 9.78. So I'll show that on a calculator. That's what t squared is going to equal. So take my trusty calculator, take 888 divided by 9.78. Gives me that ugly, I'll just write down 90.7975, and so on. It is better not to round that. So when we take the square root, okay, we're basically taking the square root of this fraction, okay? Don't round until the very end. So to do this on a calculator, I hit second, x squared, there's my square root. Instead of just typing in 90.797 something, I can just hit second, and then down here is the negative, where above the negative is the answer. If I hit second negative, it then uses this line right here. So I hit enter, and I see it's going to take about 9.53 seconds, round to 2 decimal places. That's, oh, I actually said the tenths. So technically I'll round to, I better read my own directions. It would just be 9.5 seconds. Okay. Surprised I forgot I didn't say the hundredth. So round your answer to the nearest tenth. That would be just to the 5. Okay. So think about that. That should be an easy application problem. Okay, next page. This whole page we are solving, and I don't care which technique you use. So if you looked at that flow chart that I provided, you have 3 techniques that you can try to solve a quadratic with. You have square root method, we have factoring, if it can be factored, and the quadratic formula. Okay, so for this first problem, I cannot use the square root method because it's an x squared and an x term. Cannot solve by the square root method. So you could say, okay, I want to try to factor this, but unfortunately, you're not going to be. If it takes more than, say, a couple seconds to figure out what the factors would be, then you are forced to use the quadratic formula. So it's already equal to 0, so that's a good news. I can easily pick out my A, B, and C. Okay, so as soon as I pick out A, B, and C, I'm going to substitute these into the quadratic formula. Opposite of B, in this case, is 3, plus or minus. Please put this in parentheses before you square it. Okay, negative 3 squared is a 9. It must be in parentheses. The calculator reads that as negative 9. Minus 4 times A times C, all over 2 times 1. So we're going to clean this up. I always want to know the discriminant. Discriminant is that number underneath the square root, which in this case, it's going to be -3 squared, or simply do 9, okay? Minus 4 times my A times my C. I see it's -11. So since it's negative, that tells me there are 2 imaginary. So anytime you have a negative root, you put the I on the outside of your radical and make this number positive. Okay, so 2 imaginary solutions, they are still solutions. Okay, they still will make the problem true. Okay, this next one I'm hoping you recognize, hey, that's a square root problem. I can get x squared all by itself in 2 steps. Step 1, subtract 2. We have 5x squared equals 220. I'm going to divide by 5. When we divide by 5, again, if you need a calculator, 220 divided by 5 is going to be 44. I take the square root of 44. Make sure you have plus or minus. On your quiz, I took a half point off if you didn't have the plus or minus. There's 2 answers. And then since this can be simplified, I want you to be able to simplify. So 44, so let me explain where that comes from. I can break up 44 as root 4. Root 11, square root of 4 becomes a 2. Okay? This next one, I must have 0. Okay? I can't even begin to solve this without having 0. Okay? Because I can't use the square root method, so it forces me to get this in standard form. X squared minus x minus 20. Now, again, I've been doing this for a long time. I know the factors. I can look at this. I know this factors. So I'm going to do 2 sets of parentheses. And I know it's plus minus because I need a -20. And that adds up to a -1. So I know my 5 is going to be negative. My 4 is going to be next to the plus sign. If I quickly check x times x, x squared, my outers and my inners will add up to a -1x. 4 times -5 is -20. So I have the factors, and then I figure out my solutions. -4 makes this 0. 0 times anything is 0. And on this factor, what makes it 0 is a +5. Those are my solutions. And you could type this in your calculator, and it would be your x-intercepts. Okay, so very easy to check. This one here, I'm going to subtract an x, get this in standard form. And oops, I need a 7 here because 8x minus x is a 7x, and then I have -6 equals 0. Again, I cannot use the quadratic formula, cannot factor unless I have equal to 0. Okay, so now this one, I have a -12 to add up to a 7. I can't think of the factors off the top of my head. So this would be a little bit harder if it can be factors. So what I can check is the discriminant, okay? If your discriminant is a perfect square, that means we could factor this problem. So then we could take some more time to try to find the factors. But again, we can always use the quadratic formula. So A is 2, B is a 7, C is a -6. So I'm going to quickly figure out the discriminant, which is 7 squared, b squared, minus 4 times my a times my c. Okay, it's 97. So 97 is not a perfect square. That means I can't factor this to begin with. So I must use the quadratic formula. So it's -7 plus or minus the square root. Now I just calculated, I know it's going to be a 97, but I'm going to show this just so that I have this part on paper. All over 2 times 2. So on your test, if you use the quadratic formula, you will not need, unless it's a perfect square, which means you could have factored it, this 97 I can't break up anymore. So I'm finished. So you can stop right there on your test. The big idea is, remember, they made you type this in twice. You had to use the plus sign and then retype it as using the minus sign. Okay? So the next one, number 11, I have x squared minus 15x. I always like keeping this positive. So you say, why don't I just subtract an x squared? I don't like to do these quadratics when a is negative. Okay, so I'm going to keep this positive. I'm going to bring this over, and I'm going to add 56. And if you can factor, if you can think of the pieces that adds up, again, ways of getting 56, 7 times 8. 7 times 8 is 56, and it will add. So I can actually factor this pretty quickly. Again, if you didn't recognize that, you could have used the quadratic formula, but the discriminant will be a perfect square. In fact, let me show you that. Let me just show you that if I take my b value, which is 15, negative 15, I square it minus 4 times my a times my c, I get a 1. The square root of 1 is 1, which means we could have factored this, and you might as well factor x minus 8 and x minus, what is that, 7. Okay, so 8 and 7 are my zeros. Okay, so again, if you're having a hard time factoring, then use the quadratic formula. Okay, so number 12, square root method again. So you need to recognize I don't have an x term, so I can easily subtract a 1. So let me show that. Minus 1, we get negative 150. I'm going to divide by 6. Negative 150 divided by 6 is negative 25. Take the square root, and I need the plus or minus, and it's just going to be a 5i. Okay, square root of 25 is a nice number. 5, since it's negative, it's going to be an I. Okay, 2 more in this page. I need this in standard form, so I'm going to bring this over. So I have a 7x squared. I have minus 15x, and then that's going to be a positive 2. Okay, so again, when in my head, I'm looking at this. Can I break this up into factors? And I can actually solve this. Okay, I can use the AC method. I need a 14x squared to add up to a negative 15x. Okay, and you say, how's that even possible? Negative 14x and a negative 1x. That satisfies that diamond. Since I was able to find that, that means I can factor it. So I'm going to replace the middle term with a minus 14x and a minus 1x. Split it down the middle. Remember, I'm not changing the problem, but it allows me to split it down the middle. On this side, I'm going to put a 7x on the outside, x minus 2 in parentheses. I must have an x minus 2 on this side for this to work, which means I would need to factor out a negative 1. Negative 1 times x is negative x. Negative 1 times negative 2 is a positive 2. Again, we're not changing this problem. And then my factors, so that's that AC method that we did in our notes. This and this make up a factor, and then this is my other factor. If you can do this in your head, what makes 7x minus 1 0 is 1 over 7. I add a 1, divide by 7. 1/7 turns this into 0. 0 times anything is 0. What makes this, you can do real easily, is a positive 2. Again, if you're going to use the quadratic formula, your discriminant would be a perfect square, which would mean I would want you to simplify it. Okay, now this 14, so easy. It's super easy, but people are going to get this wrong, just like people got it wrong in their quiz. And I don't know how else to say this. Get 0. And what you're going to see is you're just left with x squared minus 6x. Okay, I know it looks goofy. It's not a trinomial, but it's so easy to factor. Just factor out an x. So simply put an x on the outside. X minus 6 would be inside. And your answers, one answer is 0. Obviously, plug in 0 for x. You're left with negative 11 equals negative 11. The other solution is a positive 6. Okay, 6 squared minus 6 times 6, 36 minus 36 is 0. Negative 11 equals negative 11. It works. Okay, last page. And this is a lot longer than the actual test. And we're at the 20-minute mark of me going over this and trying to explain in detail every single problem. So here's a revenue question, just like the revenue question that you got to practice on the practice quiz that you saw on your actual quiz. We're going to see another one on the test. Okay, I want people to understand these. So right now we're dealing with our revenue that's dealing with what? Songs and the price per song. Okay, so right now we can see we have a price of $1. I'm going to put my price first, it doesn't matter. But right now we're charging just simply $1 for a song. And at that rate, we can sell 4,000 songs a day. So each day, we are going to see if we can increase our profits. Right now, if this is the conditions, we make $4,000 a day. Okay, I would be happy to make $4,000 a day, but let's see if we can change the price and see if we can increase this. We're told, so I read right here, here's the rate in which we're increasing. Okay, we're increasing $1.05 every time. So I put plus, since it's an increase, this will be the plus. Here's your rate. And then your X, we don't know how many times we're going to increase it. Can we increase it 10 times? That's what we're going to find out when we find the vertex. By increasing the price, that will have an inverse effect, meaning we're going to then decrease the number of songs that we're going to sell. So we're told every time we increase, we sell 80 fewer songs. So the rate in which we're decreasing is minus 80x. Okay, this is a linear situation. This is what you learned in Algebra 1. These two factors are linear, and when you multiply them, that's what makes it quadratic. So at this point is when we will pick up our trusty calculator, go to the y equals screen, and type in this situation. So there's my money, and then the number of songs, 4,000 minus 80, and then don't forget your X. Again, if you don't have that X, there's no way the calculator is going to give you the correct answer. So we need to find the vertex. So it looks like the vertex occurs pretty quickly. Let's see. Wait a second. Oh, I forgot my X here. I knew something was wrong. I need to insert an X. And I'm not going to re-record this. So I went to my table. I did this on purpose. So anyone watching this, I did this on purpose to illustrate that if you don't see a vertex, check your rule. We have to be able to see a vertex in our table. So I originally forgot that X. It's there now. When I go to my table, I now see that this now makes sense, because if I don't change the price, it's 4,000. If I increase, I can see how my prices or my revenue is still increasing. 6 times, it's still going up. 7 times, it's going up. 8 times is more. 9, it gets to 10. 11, it's still going up. 13, still a higher number. 14, 15, and then it comes back down. So I need you to realize, again, it took me a while to scroll until I could find the vertex, but my clue is, here's my X, here's my Y. X is 15. That doesn't mean we're charging $15 for a song. No one's going to pay $15 for a song. And our revenue, our max revenue, is $4,900, $4,900. So what this means, to answer the questions, so we wrote our expressions to maximize revenue. What should the store charge per song? We're taking this 15 and plugging it in for X. So I go to my blank screen. If I can't do this in my head, 1 plus really a nickel times 15. I'm increasing the price 15 times. So I should charge $1.75. Okay. By charging $1.75, fewer people are going to be willing to buy the song, but I'm still going to make more money. So 4,000 minus 80 fewer people every time I increase the song, which I'm increasing 15 times, that means I'm only going to sell 2,800 songs, but I can see 2,800 times my price. There's my max revenue. My max revenue, $4,900. That's what I need. The price, the number of items, and the max revenue. Every single problem's done the same way, okay? You should be able to handle that. So really, that's your test. I actually put some extra problems on just for practice. Now, I did ask a discriminant on your test, but this is just some extra practice on the AC method because that's new since the last time since I gave an assessment. So let's quickly go over these and then we'll be done. But that took me 25 minutes to go over. The test should be done in a period. If you know what you're doing, you don't get stuck, we should be able to answer the questions on the test in a period. So let's practice some more. The AC method. So the AC method, that is where we must have zero. So we're just going to practice factoring. I'm going to find the pieces. And once I find the pieces, then I can tell you the solutions. So right now I have 6p squared plus 5p minus 6 equals 0. I don't know the solutions. I have no idea what P is to make that 0. But if I do A times C, negative 36x squared, I guess it's P squared, sorry. Since I'm using the letter P, I guess I should use P. P squared, that adds up to a 5P. My brain's already working. It's already thinking of ways of getting negative 36 that could possibly add up to a 5. I know negative 9p and a 4p, okay? Actually positive and negative, so it adds up to a 5p. 9 times negative 4 is negative 36. My sum adds up to the positive. I'm going to replace the 5p with a positive 9p and a minus 4p. Together, it's still a 5p, so we're not changing the problem, but it's going to allow us to split this down the middle, factor out the GCF. So on this side, you must factor out a 3p. 3 times 2p gives you the 6p squared, and then plus 3. I'm basically dividing 9p divided by 3p. That's where the 3 comes from. Okay, but if I distribute, I'm back to that previous line. So I must see a 2p plus 3 on this side. So what number must be put on the outside is a negative 2. Negative 2 times 2p is negative 4p. Negative 2 times 3 is negative 6. We factored correctly. So this and this makes up one of my factors, and then the 2p plus 3. So now I still have to tell the solutions, but it's really easy. Again, I can do this in my head. If you can't, off to the side, set this equal to 0. You would add a 2 and divide by 3. 2/3 is an answer. This factor, when you set it equal to 0, I would have to subtract the 3 and then divide by 2. So I get negative 3/2. But those are your solutions, okay? Another practice using the AC method. I subtract 8, 7b squared plus 13b plus 6. Again, unfortunately, if you make a little calculation mistake, there goes any hope of being able to factor correctly. So just be careful with your calculations. And now I should be able to set up this problem. AC 42b squared, 13b. My brain already figured it out because it's really the numbers that I see here. 7 plus 6, that is a 13. So I'm going to break up 42 as 7b and a 6b. 7b squared plus 7b. If you wanted the 6b there, you certainly could. Doesn't matter the order here. But since I started with 7b, I'm going to have 6b plus 6 on the other side. I factor out a 7b, b plus 1 inside. Here I factor out a 6. I feel good about this because I see the b plus 1 on each side of my line, my wall. 7b plus 6 is a factor. B plus 1 is a factor. Easy part, subtract a 6, divide by 7. Over here, what makes this 0 is a negative 1. Those are my solutions, okay? So then here's some more practice on the quadratic formula. already in standard form. A is an 8, B is a negative 11, C is a 9. So if you're going to use a quadratic formula, I'll give you a point for correctly telling me A, B, and C. Then I will give you a point for correctly substituting into our quadratic formula. Opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. Once you substitute everything in, I would want you to clean this up. I would want you to successfully tell me the discriminant, which in this case, negative 11 must be in parentheses before I square it. It needs to be 121 minus 4 times 8 times 9, and I get negative 167. The only thing I'm going to ask you to do, if it's a negative, show me that it's imaginary solutions. Okay. 167. Now, for these, I promise you, you will not have to waste any time on the test trying to figure out if there's a perfect square. You're not going to need to simplify. Now, again, if it's a perfect square, then I would want you to factor it. So this, we're using the quadratic formula, and we are finished. Okay, 2 imaginary solutions. This one, I add an 8, 12a squared minus 9a minus 7. Again, don't get calculations wrong. There's nothing wrong. It doesn't take long to double check your calculations. Okay, so if you can't do them in your head, don't make them as a silly calculation mistake, because that's going to throw you off. So now that it's in standard form, I got 0. A, B, and C are super easy to pick out. I substitute everything in. 9 plus or minus negative 9 in parentheses squared minus 4 times my A times my C all over 2 times 12. Okay, so when I clean this up, I'm going to have all over 24, and I want to know the discriminant. Okay, so I know that should be 81, but I'm going to type it in, and as long as I have negative 9 in parentheses before I square it, it's going to give me the correct answer, times 12 times negative 7. So again, just type in exactly what you see underneath the square root. Hit enter, and I see it's a 417. I write 417, and I'm finished. Okay, I don't need the decimal answers. I don't need you to tell me 9 plus the square root of 417, enter, divide by 24. I don't need that for your test. Okay, last two, just so that you're aware, you practice this on big ideas. This is just telling me the value of the discriminant, and then tell me the type of solutions. So without actually solving this, it's already equal to 0. All I'm going to ask you is to calculate b squared minus 4 times a times c. Okay, so I have no idea what that is. So let's ask the calculator what negative 3 squared, like that in parentheses, minus 4 times negative 10 times negative 4. It tells me it's a negative 151. Since it's negative, 2 imaginary solutions. Okay, the reason it's negative, I would have an I in my solutions, which means they're imaginary. Okay, anytime the discriminant's negative, you will have 2 imaginary solutions. So if I did go on to solve it, it would be plus or minus I root something. Okay, this other one, I'm going to keep this positive. I'm going to add a 6m, and I'm going to add a 3. Okay, so my A is 3, my B is 6, my C is 3. If you subtracted and you have A as negative 3, you would still get the same value of your discriminant. Okay, so for this problem, it's easy to take 6 squared minus 4 times 3 times 3. Hey, that looks like it's going to be 0. Let's see. Is it 0 minus 4 times 3 times 3? hey, it is a 0, which means there would only be one real answer, one real solution. Okay, plus or minus the square root of 0 is 0. So you would basically have the opposite of b over 2a as your solution. Whatever that number would be your only answer to that equation. Okay, so that's the discriminant. It is now at the 35-minute mark. I did a lot more problems than what you're going to see on your test. Okay, so we should have plenty of time to do it, but you need to practice. So in addition to all this, you have your big idea assignment on the quadratic, and then in your notes, I have plenty more practice problems that you can practice solving the quadratic formula, practice factoring, practice the square root method. We need to be good at solving quadratics. Okay, so thank you for watching. Have confidence when you do take the test on Thursday that you can do this. Okay, thank you for watching.